Good morning to all. Now, in the previous session we concluded how to prove a given system is linear or non-linear. Before that, we already discussed 4 other systems. Now, in this session, we are going to discuss the 5th kind of system. Let us start. Now just look at here, we are going to begin with the 5th kind of system. The system is called linear time variant. Linear time variant and linear time invariant. Linear time invariant systems. Linear time invariant systems. Look at this concept is also very important. Simply what we write is called linear time variant and linear time invariant. Linear time variant, linear time invariant systems. These are 5th kind of systems in the series of systems. Now, students have to very clearly observe upon the terms given in the sentence. Linear, time, variant, linear, time, invariant. Look at these two are same. These two concepts are differing from each other only in the variance and non-variance. That means invariance only. Now just look at how to make it. First, linear time invariant. Linear time invariant. That means what? This property contains 2 sub-properties. One is invariant systems. First is called invariant system. Second one is called linearity property. Linearity property. Look at linear time invariant contains 2 subtopics. That means what? Linear time invariant systems equal to linearity property plus invariant property. This is linear time invariant. When can we say that a system is? When can we say that a system is linear time invariant system? When can we say that a system is linear time invariant system? That means what? It has to satisfy 2 important properties. One is invariant, second one is linearity property. Now just look at proof. Proof means what? A system is linear time. A system is a linear time invariant. When can? The first property is called what? Linearity property. Just in the previous case, we discussed what is the linearity property. Linearity property is what? Transformation of like a1 x1 of t plus a2 x2 of t. It should be equal to a1 L of x1 of t plus a2 L of x2 of t. This is the property. That means what? Transformation of sum of signals. Single transformation of sum of signals is equal to sum of transformation of signals. Previous concept we already discussed many times that property is to be satisfied. Second one, invariance. Invariance means what? For any signal y of t, if a time delay is introduced, it should be equal to y of t minus t naught. This is the invariance property. This is called the invariance property. If these 2 properties are satisfied, that system is called linear time invariant. one important thing just we have to make it that linear time invariant is a hybrid system, because linear system is different, time invariant is different. In the previous classes we discussed what time invariant system, what linearity system. Now these two concepts are combined together and made into a single system. That system is called linear time invariant. So students have to make it, first divide the concepts. So analyze the given concept. Upon analyzing, two important points we are going to get. One is called invariance property, another one is called linearity property. So in the before case, we discussed this property as a single system. We discussed this property as another system. Now these two different systems are combined together, and just we call that combined together as linear time invariant systems or linear time variant systems. Now in the first instance itself, we begin with linear time invariant. I stands for invariant. So here the first property what is to be satisfied is that transformation of sum of signals is equal to sum of transformation of signals. That is linearity property. Time invariance means what? For any given signal y of t, if time delay is introduced, t naught is what? T naught is called delay. If delay is introduced, then the output is equal to y of t minus t naught equal to, then it is called invariant. Again I am make you remembered the concept what we discussed. Take any system. We will give input. For the corresponding input we will get the output. That means what? We give another input to. We will get the corresponding output to y2. So the first input y1, x1, we get y1. For the corresponding input x2, we will get y2. That means what? Whatever the input you give, the corresponding output we will get. These two should not be changed according to time. Whether you exercise this input now or tomorrow or day after tomorrow, wherever and wherever, irrespective of the geographical locations, whatever the input you give, the corresponding output, it is able to give properly. That is called, there is no influence of time on that system. That system is called invariant system. This is called invariant system. Now, this is the first one. Now, just you go for now. This is the linear time invariant system. Now, the next concept is called linear time variant system. The second concept is called linear time variant system. What is linear time variant system? That means what? Linear time variant, that means it contains linear time variant system. Now just what we discussed, linear time invariant system. Now just we are going to discuss linear time variant system. Now just look at. Now what we are going to get, linear time variant system. Now it contains two parts, just as we discussed in the previous way, linearity principle, and second one is called variance principle. That means what? Linear time variant system is a hybrid system that is a combination of linearity property plus variance property. That is called linear time variant system. So for example, first one is what? Linearity. First one is called linearity principle. Just what we discussed in the previous one, a1 x1 of t plus a2 x2 of t, that should be equal to L of x1 of t plus a2 L of x2 of t. So that means what? Transformation of sum of signals equal to sum of transformations of signals. The first principle it has to satisfy is linearity. What is the second one? Variant principle. Variance. Here variance means what? Time variance. Variance means what? Time variance. For any given signal y of t, if delay is introduced, this is not equal to y of t minus t naught. That is called variance. So the definition of variance is clear opposite to the definition of invariant. That means a system is there, you will give one input, you will get the corresponding output in the first instance. In the second instance, if you give the same input, you can't get the exact output. It will give another output. In another instance, it will give another output. That means what? It is not depending on time. Understand? It depends upon time. Depends upon time. That means what? There is no guarantee that it will give exactly the correct output at all instants of time. That means what? It is a time dependent. That's why it gives various outputs. Various outputs. That's why at any time, if this is not equal to one output is not equal to another output, it is not equal to. In this way, the system is called time variant system. Time variant system. Look at that means whether it is time invariant or variant, these two should be verified. Linearity is common, time variant or invariant, these should be verified. These two are should be verified. Now I will give these two in a single capsule. Now just look at. Now just look at system. Now how I am making it as systems. This system is called linear time invariant. This system is called linear time variant. Now just look at. Now let us create a binary tree. Now just look at linear time invariant. This is giving a linearity property. This is linearity property plus linearity property plus invariance, time invariant property. Now come this side, linear time variant property. What does it give? Again it gives linearity property plus it gives variant property. Time variance. Variance means what? Time variance. Here invariant means what? Time invariance. Now just look at, this is the correct exact classification of linear time variant and linear time invariant systems. So this is the exact clear-cut picture of linear time variant and linear time invariant systems. Invariant systems. Now just look at how the configuration, the classification goes to be. Now systems can be LTI invariant, LTV variant. Whether it is LTI or LTV, we have to verify these two conditions. What are these two conditions? Linearity principle and whether it is variant or invariant. These two are to be verified. If it is invariant along with linearity, linear time invariant. If it is time variant along with linearity, that is called time linear time variant systems. These two are very much important. Now regarding the practical concept, regarding the practical use, for practical use we always consider linear time invariant systems only. We always consider linear time invariant systems only, not linear time variant systems. So these two differences students have to find out very clearly in the series of systems. This is the end of the fifth system topic, that is linear time variant, linear time invariant. So whether a system is given, students have to analyze what kind of terms does it contain. According to that you can analyze. So you can split the concept into two ways. For example, linear time variant, split the concept into linearity property and time variance property. You will automatically get the output like that. So this binomial structure, binary structure is very much important to make distinction between these two concepts. Thank you. This is the end of the differences between linear time variant, linear time invariant systems. In the next session, we are going to begin with another systems. Thank you.